Think about what the inverse of different operations would be. If we have addition, the inverse of addition would be subtraction. If we have multiplication, the inverse of that would be division. If we had taking something to the second power, the inverse operation would be square root. Now doing functions will also have their inverses. And when that happens, the inverse of an x value would be a y value. So when we go to find inverse functions, you just change your x's with your y's. Now we're going to do an example where we find an inverse function, but before we do, we need to note that an inverse function needs to be one-to-one, meaning that for every x value there is only one y value, and for every y value there is only one x value. For these problems, we are going to assume that they are one-to-one. So let's say I have f of x equals 2x plus 3. And there's our function. So in order to find our inverse, the very first thing you want to do, and it's really just helpful in notation, is to take your f of x and replace it with your y. Because f of x and y are really the same thing in this case. So we can take our y and our x, and to find the inverse, we just switch them, because an inverse function means that all x's and y values are switched. So instead of y, we have x, and instead of x, we have a y. Then, in order to solve for the inverse, we just solve for y. So let's subtract the 3 over. X minus 3 equals 2y. And then, to get the y by itself, we're going to divide everything by 2. So then we get y is equal to 1/2 x minus 3/2. And now we have the inverse. So we can write that as f inverse of x equals 1/2 x minus 3/2. This would be the inverse of our original function up here. Alright, some cool things about this is that if this is the domain here, the domain are the values of x, and the range for this one are the values for y. In our inverse, those will switch. Okay, so the range of my original function will be the values of x, and the domain of my original function will be the values for y in my inverse. Okay, let's look at one more example. Okay, so it'll be a little bit harder. F of x equals 1 over x minus 5. Okay, really quick, what is the domain here? My pen does not want to write that word. The domain is that x cannot be 5. Alright, so let's go and solve for the inverse here. So we switch our y with, or our f of x with our y, just for notation. And now, to solve for the inverse, we have our x values switched with our y values, and our y values switched with our x values. So every x becomes a y, and every y becomes an x. Okay, remember that I told you in a previous class that in order to get anything out of the denominator that you're solving for, it needs to let me rephrase that. In order to solve for a specific variable, it cannot be in the denominator, so we need to get that out. Y minus 5. So we have y minus 5 times x equals 1. Let's distribute that x through, so we get xy minus 5x equals 1. Alright, add, we want to solve for y, so we're going to add that 5x over, 5x plus 1, and then let's divide by x. Okay, so we get that y equals 5x plus 1 over x. So this would be our inverse. Okay, the right notation for that would be f inverse of x equals 5x plus 1 all over x. Okay, now let's look at our inverse. What is the domain of the inverse? Okay, so we have the domain here would be x cannot be 0. So we can figure out what each function's range is based off of knowing the original function's domain and the inverse's domain. So the range of my the range of my original function is equal to the domain of my inverse, except for that the values are y values when you're dealing with range. Okay, and our range of our inverse are the values for our domain in the original function. Okay, so what you need to remember is that when you're finding a function's inverse, you just need to switch all the x's and the y's, and that includes finding the domain and range values, the x and the y values.